Hello everyone. In the previous session we have learnt about positive integers that are simply counting numbers 1, 2, 3, 4 and so on. In this session we are going to learn something more on these positive integers. So let's take some positive integers, say 12, 30, 42 and 18. So can you tell me what is common between these positive integers? Well, as soon as we look at these numbers, we see that they are all different numbers. But let me tell you, there is something common between these numbers. And to find out that common thing, let me first write down these positive integers as product of two numbers. So if I start with number 1, I can write 12 as 1 into 12 in terms of product of two numbers, that is 1 and 12. And also I can write 12 as 2 into 6 because 2 into 6 will also give us 12. Also we can write 12 as 3 into 4. So this is the only possible way of writing 12 as product of two numbers. Similarly I can do for the numbers 30, 42 and 18. So here the numbers that we use to get 12, that is 1, 2, 3, 4, 6 and 12. They are all called as the factors of number 12. And note that here 1, 2, 3, 4, 6, 12 also divides 12 completely. So they are also called as the divisors of number 12. Similarly, this goes for every number. So now if I talk about the common thing, we can see that here 1, 2, 3 and 6 are the common factors of all the numbers. And out of these common factors, 6 is the highest number, which is a factor of all the numbers. So here 6 is called as the highest common factor of 12, 30, 42 and 18 or HCF. And also since 6 is the greatest number that divides 12, 30, 42 and 18, so highest common factor is also called as greatest common divisor. So now as we know that, what do we mean by highest common factor or the greatest common divisor? So in mathematics we have two methods to find the highest common factor, multiplication and division. So let's say if I want to find highest common factor of the number 30 and 15. So let's first see how can we find the highest common factor by multiplication method. So here we have two numbers, that is 30 and 15. And we already know how to factorize a number. For example, we can factorize 30 as, this means that 30 is equal to 2 into 3 into 5. Similarly, we can factorize number 15 and we can get 3 into 5. Now here to find out the highest common factor by multiplication method, we'll take the product of the common numbers. So as we can see here, 3 is common and 5 is common and no other number is common. So we take the product of 3 and 5. That is 3 into 5 is equal to 15. So here the highest common factor of 30 and 15 is equal to 15. Let's now see how can we find the highest common factor of 30 and 15 by division method. So in division method we will first divide the two numbers and we'll get remainder is equal to 0. And we know that whenever we divide any two positive integers, the bigger number is called as dividend and the smaller number is called as divisor. And here 2 is called as quotient and 0 is the remainder. And we know that 15 times 2 will give us 30. So we can also write 30 as 15 into 2 plus 0, which is same as to say dividend is equal to divisor into quotient plus the remainder. So from multiplication method we know that the highest common factor of 30 and 15 is equal to 15. So here also 15 should be the highest common factor. And here 15 is nothing but the divisor of 30. So here we conclude that in division method whenever we divide any two positive integers and if we get remainder equal to 0, then we consider the divisor as the highest common factor of that numbers. So we can see we have got the same answer by both the methods, but this was the case where the remainder was equal to 0. But what if remainder is not equal to 0? So let's say instead of dividing 30 by 15, if I divide 32 by 15, I'll get remainder as equal to 2, that is not equal to 0. and I can write 32 as 15 into 2 plus 2, that is dividend is equal to divisor into quotient plus the remainder. So at this stage, only because this remainder is not equal to 0, so we cannot say that the divisor 15 is the highest common factor. So here to find the highest common factor, that is here to make this remainder equal to 0, we'll consider this found remainder as the divisor and this divisor 15 as dividend. And we will again divide 15 by 2 and we'll get remainder as equal to 1, which is again not equal to 0, and again I can write 15 as 2 into 7 plus 1. So again we can see that the remainder is equal to 1. This means that here also we cannot consider this divisor as the highest common factor. So again we will perform the same step, that is again we will consider this found remainder as divisor and this divisor of the previous stage, that is 2, as dividend. And we will again divide 2 by 1. So here 1 will go 2 times and the remainder is 0. And 2 can be written as 1 into 2 plus 0. So here since the remainder is 0, we can say that the divisor 1 of this stage is the highest common factor of 32 and 15. If we want, we can cross check the same by a multiplication method. So we have two numbers 32 and 15 and we can factorize 32 as and 15 as. So we know that to find the highest common factor we have to take the product of the common numbers. There is no common number between 32 and 15, but just remember 1 is a factor of every number, means 1 is multiplied with every number. So here 1 is the highest common factor of 32 and 15. So we have got the same answer. So we have seen two methods of finding highest common factor, that is multiplication and division. But you might be thinking where to use multiplication and where to use this division method. Actually earlier when people wants to find the highest common factor, the most common method was the multiplication method. But later on they found difficulties in finding the highest common factor of bigger numbers. So let's say if I want to find the highest common factor of bigger numbers like 42,237 and 33,345. So here it would be difficult for me to list down all the factors of such bigger numbers and then to find out the highest common factor. So instead of going by this multiplication method, I would prefer to go by division method. So let's divide the two numbers. So this will go one time. We can write this as 42,237 is equal to 33,345 into 1 plus 8892. So here as we can see that the remainder is not equal to 0. So let's consider this remainder as divisor and this divisor as dividend for the next stage. So this will go 3 times. So let's do this until we get remainder equal to 0. So here since the remainder is equal to 0, so here we can conclude that the divisor 2223 is the highest common factor of 42,237 and 33,345. So this is when the Greek mathematician Euclid has come up with an idea, and he proved that whenever we divide any two positive integers, we get two more positive integers in the form of quotient and remainder, and then they can be arranged as dividend is equal to divisor into quotient plus the remainder form. And this type of representation is called as lemma in Greek, and since this is proved by Greek mathematician Euclid, so it's called as Euclid's division lemma. And he proved that in this lemma, if the remainder is 0, the divisor will be the highest common factor, and if remainder is not equal to 0, we will use this lemma until we get remainder equal to 0. And the process where we apply this lemma to get remainder equal to 0 is called as Euclid's division algorithm. So that's all for now. Let's go back and check what all we have learned in this session.
The complete course for Grade 10th CBSE Math is available in Pendrive and SD card format. Click on the link to buy now. To know more, you may also check the description box below.